Hi, my name is Chris Boehner with FLIR Systems. Today I wanted to talk to you about the new FLIR thermal benchtop test kits. We're going to take a look at a couple kits here and a sample application. But before I do that, I wanted to show you some of the advantages of infrared cameras offer for thermal temperature measurement over traditional forms of temperature measurement. Let's take an example here. If we were wanting to measure and do research and development on a light bulb, let's say that we wanted to measure the surface temperature to ensure that it doesn't get too hot and potentially overheat and cause issues when it's out being used by customers. If we're to use traditional forms of temperature measurement, such as spot pyrometers or thermocouples, we get a single point of temperature measurement. So it's kind of like what you see here in this graphic. It only gives you a small window as if we're peeking through a couple pinholes within a black shroud. But with an infrared camera, we're able to see the full thermal characterization of our part. So we can see not only hot spots, but we can also see cold spots and see how the gradients transitions across the part. And so this would allow us to better characterize and measure and develop our light bulb for this application. And that's some of the advantages of infrared. Millions or thousands, tens of thousands of points of temperature measurement, non-contact at the push of a button. Let's take a look at this as if we were going to develop a light bulb. When we think about the product development life cycle, there's kind of three major phases. There's a research and design phase, a manufacturing test phase, and a quality assurance phase. And they all kind of feed back on each other. Let's focus on the research and design phase and the quality assurance phase today during our webinar. So if we think about research and design, maybe we're talking about a printed circuit board. And when we look at a printed circuit board, we're looking for hot spots that may indicate failures or issues in our design, or maybe we're just trying to design a better board to be able to thermally dissipate the heat that comes from our parts. As they get smaller and faster, I mean, you think about the devices that are in your pocket probably right now, or maybe you're looking with an iPad device or an Android device right now as we look at this webinar, and when they design those devices, they need to dissipate the heat and be able to make it comfortable for you to hold the device. And so when they build that design, it's critical that they know the thermal characterization and how the temperatures dissipate across their device. So that's a great way to use thermal measurement for the R&D research and development phase. Then if we look at the manufacturing process phase, here's a sample image of looking at an iron ore processing. Here maybe we want to draw a line across it and ensure that it has even heating distribution. In this particular image, we see a hot spot, which may indicate a problem with the process. And so again, thermal cameras allow us to get non-contact temperature measurement and thermal characterization to help gain better insight into our process. And from there, we might look at the quality assurance phase. And you're probably asking yourself, right now we're looking at a beehive. How is that quality assurance? Well, as it turns out, we actually have a customer using a thermal benchtop test kit for exactly that. This customer's end user ships bees around, and they want to be able to tell the heat of the colony because that gives them an indication of how many live bees are inside the colony when they ship it. When it ends up at its final location, they want to make sure that the temperature is near that same scale to ensure again that there's the same quality or number of live bees in the colony when they shipped it to when it actually arrived at the location. Very innovative application and one you normally wouldn't think of when you think about thermal measurement or benchtop test kits, but definitely one where the thermal benchtop test kit offered advantages for quality assurance. Now another piece that isn't part of the product development life cycle, but definitely is one you should consider is sales and marketing. What better way to tell customers about your product and how it works thermally than with an infrared camera picture or a movie? In this instance, Columbia Sportswear was taking a look at designing new coats. And here you can see a visible image of a person without a coat and the heat loss that's happening, and then them wearing the coat, again invisible and thermal. It tells a really telling and interesting story just by showing a movie of a person putting on a coat and seeing that it's holding all their heat energy inside and keeping them nice and toasty and warm. So it's great for sales and marketing opportunities as well. So how do you measure temperature currently? Well, if you're using some of the legacy forms of temperature measurement like thermocouples, spot pyrometers, or maybe you're not even measuring temperature at all in your product, you may not be getting the full story. An infrared camera gives you tens or hundreds of thousands of points of non-contact accurate temperature measurement to help you out in all phases of your product development cycle. The R&D phase, the manufacturing process phase, the quality assurance phase, and then also the sales and marketing aspect there. The benchtop test kits we offer today are the FLIR A65 and A35 SC. Both of these are fixed mount cameras. The A35 has a 320 by 256 pixel resolution, and the A65 has a 640 by 512 pixel resolution, so 4 times the number of pixels. Both come with a built-in lens, stand, and Research IR software, and they're fully temperature calibrated, so they stream the data over gigabit Ethernet to the computer for live image viewing, recording, analysis, and data sharing. The data sharing is a nice part to consider because then you can feed that data right back into your R&D phase and help improve your products. The third benchtop test kit is the FLIR E40 SC Thermal Benchtop Test Kit. Now this one is a handheld portable kit. You can use it autonomously to take snapshots and do analysis on your targets, or you can tripod mount it and stream the data over USB, again to the FLIR's Research IR software for live viewing, acquisition, analysis, and data sharing. And then finally we have the T420 Portable Benchtop Test Kit. This has 76,800 pixels of non-contact accurate temperature measurement. So it's the highest resolution in the man-portable systems. We can also tripod mount this camera and stream the data over USB again to the software to allow us to do benchtop work or take it out in the field to collect data. The last benchtop test kit is a T430 SC benchtop test kit. This has 76,800 pixels of non-contact accurate temperature measurement. You can use the camera out in the field by itself, or you can tripod mount it and stream the data over USB to a computer for live acquisition, analysis, and data sharing like we mentioned previously. So those round out our 4 different benchtop test kits, 2 fixed mount and 2 handheld portable that can also be fixed mount. Now let's take a look at a demonstration of the benchtop test kit. So let's take a look at our setup here today. I have 2 different cameras. One is that T430 SC man portable benchtop test kit, so I can go and take some measurements on my device, handheld, pop out the SD card and do some analysis with the Research IR standard software. Or I could tripod mount this and stream the data over USB to my computer. I also have set up the A35 SC benchtop test kit with its included gooseneck stand, streaming the data over gigabit Ethernet to a computer again for live viewing, acquisition, analysis, and data sharing. And the product we're going to look at today, if we think about the product development cycle, is a heating pad. So in the R&D development, maybe I'm working on a new circuit board that controls the temperature of the pad. Maybe I want to look for quality assurance to make sure that there's no cold solder joints or issues. Or maybe in the R&D phase, I just want to make sure that it's working optimally without getting too hot or uncomfortable for the user to hold on to. In addition, of course, we can look at the heating pad itself and make sure that the elements are all working correctly. There's no issues or breaks in the line there that we should be concerned of. Maybe we also see how long it takes to reach its set point temperature and make sure that it doesn't get too hot. And then we can also look for uniformity. Ideally, this pad's going to heat up and the entire thing will be one uniform temperature without significant hot or cold spots. So that's another research and development, or maybe even a quality assurance phase checkout we can do with our benchtop test kit here today. So now let's dive into the software. I've already connected to the A35 SC camera and we're seeing the live imagery here. What's interesting is immediately I can already see kind of some hot spots, but I can definitely see the heating elements. The pad is a little bit wrinkled, so we have some unusual areas of interest down here, but kind of we'll focus all of our analysis on the flatter part up here on our device. Let's do some image enhancement first. If I go to View Palette, I can choose from any number of color palettes available to me. Let's check out Iron Bow. There you go, that kind of looks good. I can also adjust the level and span down here at the bottom, so I can really hone in on my target that I'm most interested in looking at. The next thing we'll do is record some data. So we just go in here and click on Edit Record Settings, and we have a couple options available. We can record to disk or disk periodically. Now the disk periodically is to record a few samples per second for longer durations. But today I'm going to record to disk, and I can record a specific number of frames for a certain time duration, or just push a start and stop button. Let's go ahead and just record 10 seconds of data, something to look at. I can give it a unique location to record to, and a unique name as well. I click OK, and then I just go up here and click on the Record button. While it's recording, it's going to freeze the imagery so that it can focus on capturing all the frames and not dropping any. In the meantime, let's take a look at the T430 camera. This is the one that's portable, and I can adjust the optical block and peer in to get more detail on my device here. I can record snapshots and then remove the SD card or plug it in over USB and do further analysis in the Research IR software and some data sharing. Or again, I could tripod mount this camera and stream the data over USB Live and do the exact same thing as what we're doing with the A35 camera. Looks like our recording's done. Let's go ahead and hit close and we'll open up that recording. Here it is. I'll pause it for a second so we can look at some of the different analysis tools that are available to us. We have a box, an ellipse, a line, or a spot, or a 3x3 spot. Let's grab the box and we'll just highlight this area here. And maybe we'll plot the maximum temperature within the box. So I'll go up here to my different analysis charts and graphs. And here's a temporal plot. If I click once, I get a freestanding window. But if I click on it and grab it, I can dock it below or to the right of the image. We call this customizable user interfaces. So if I dock it over to the right, now when we play through, it's going to chart out that maximum temperature within the box. So we can make sure that we don't have any hot spots that are hotter than what we allow for this particular device. Let's go ahead and grab a line profile plot as well, and I'll put that across these different heating elements. And then I'll grab the line profile plot. Now if I click once here, it throws it off to the side, and I kind of get a tab view where I can view either the temporal plot that we just did or the line profile. Or I can click on it and drag it off of there and dock it just below the line profile. So now I see both simultaneously. Let's also take a look at the stats viewer. And again, I'm going to throw that over here to the right and then pull it down and dock it right here in the middle so we can see both at the same time. If I want, I can hide the window off to the left, and now I get a nice big screen with my thermal image and the movie playing back and all my different charts and graphs off to the right-hand side. Now, usually you collect data, you do analysis, but you're going to be sharing it with someone. Maybe it's a customer or another colleague. To share data, for example, let's say the temporal plot, I just click on these two arrows and we can click and save the image as a bitmap or a comma-separated value file. Now the comma-separated value file could import into Excel or any other program that's able to take that data and do further analysis on it. We also have some options if we go to File, Export. We can export the current image as a PNG file, a bitmap, a comma-separated value file, or a JPEG image. We also can export the movie as a Windows Media Video file. So now I can share that thermal movie with somebody else, which may be the most telling story of all. Remember we talked about sales and marketing tools. This would be a great way to share details about how well my heating pad works as a product to my consumer. So that's the Research IR software. We took a quick look at how easy it is to connect up to the camera, acquire some data, do some simple analysis, and share the data.